Hi and welcome back. We're going to move on to operations with complex numbers. In other words, we're going to add and subtract and multiply those complex numbers. To add or subtract complex numbers, it works just like adding or subtracting functions, and then we're going to simply combine like terms. We're going to combine the real number parts and we're going to combine the imaginary number parts in our complex number. So looking at example 7, negative 3 plus 4i plus 4 plus 7i, I'm going to just align my like terms underneath one another because I think that is usually the easiest way to add things up. So I begin by adding my real number components. Negative 3 plus 4 is a positive 1, and 4 plus 7 is 11, and then just attach the I. So 11, how about 1 plus 11i? Once again, when we do subtraction, remember to change the signs all the way across that complex number and then combine like terms. Why don't you pause the video at this point and give example 8 a try. Okay, simplify the expression. Negative 6 minus 7i minus the quantity 1 plus 3i. Remembering, we're going to align our terms. So I have negative 6 minus 7i, and then I'm going to take the negative here and distribute it all the way across that next complex number. So it becomes negative 1 minus 3i. Then we combine our like terms, we just add them up. Negative 6 minus 1 is negative 7. Negative 7i minus 3i is negative 10i. So just like adding and subtracting functions, you combine like terms. In subtraction, change all the signs and combine like terms. Now we're going to move on to multiplication. Now, multiplication works the same way as multiplying functions. We're going to use FOIL, and we're going to multiply the coefficient parts and multiply the variable parts, or in this case, the imaginary I parts. So when we're multiplying, we multiply the real numbers and substitute negative 1 for I squared. That's the only difference. If we end up with an I squared in the product, we need to substitute negative 1. So let's look at my first expression. It says to simplify 2i times 7i. So doing this, I'm going to take 2 times 7 and then I times I. I'm just gathering my real number parts and my imaginary parts. So I'm going to have 14 and then take I squared. But I'm going to substitute negative 1 for that I squared. So this becomes 14 times negative 1. So that is negative 14. 2I times 7I. Looking at example 10, we're going to go ahead and we're going to FOIL. So that means first, 6 times 4 is 24. Outer. 6 times negative 3i is negative 18i. Inner. Negative 5i times a positive 4 is negative 20i. And then last, negative 5i times negative 3i. Negative 5 times negative 3 is a positive 15. I times I is I squared. Now I need to combine my like terms and substitute negative 1 in for this I squared. So this becomes 24 minus 38i, and then 15 times negative 1 is minus 15, and my last step then is to combine my constants. So 24 minus 15 is 9 minus 38i. Hope that makes sense to everybody. We're just doing FOIL with one additional step. When we have that I squared, we substitute in -1. Please pause the video at this point and give example 11 a try. Restart when you're ready to check your solution. Okay, let's see how you did. We're going to use FOIL. So we do outer. 4 times 4 is a positive 16. How about first, then outer? 4 times 3 is a positive 12i. Negative 9i times a positive 4, negative 36i. And lastly, negative 9 times positive 3 is negative 27i squared. Now, we need to combine our like terms and substitute -1 in for that I squared. So I have 16, 12i minus 36i is negative 24i, and negative 27 times -1 is positive 27. And my last step, combine my constants. 27 plus 40, how about 27 plus 16 is 43, minus 24i. Notice I'm always writing this in the form a plus bi in that complex number format. I hope you did well with that. We're going to continue on now. We have time on this video to go ahead and look at finding complex solutions for our quadratics. All right, if you recall, when we have our quadratic equation written in ax plus c equals 0 format, we can find the solutions to that quadratic equation by finding the square root of each side. So our first step was to isolate that x squared. So if I look at x squared plus 100, that is going to become x squared equals negative 100, just subtracting 100 from both sides. Then take the square root of each side, x equals the square root of negative 100. And breaking that down into its components, it's the square root of 100 times the square root of -1. It's going to cross the x-axis at 10i. Make that plus or minus. Don't want to forget my plus or minus 10i. Why don't you pause the video and solve example 13. Start up when you're ready to check your solution. All right, solve by finding the square root of x squared plus 1 equals 0. First step you should have done is subtract 1 from both sides, so x squared equals -1. Take the square root of both sides, x equals the square root of -1, so x equals I. So our solution is plus or minus I. Please take a few minutes, complete the guided practice on the end of this note-taking guide or at the end of this note-taking guide. Make sure you bring that with you when you return to class next time. Also, go through and do the online self-check, and we'll discuss the guided practice in class, and make sure you print off and bring your self-check results with you when you come to class. We'll see you next time, and have a nice day.